Hello, everyone. I'm Bart Massey. Welcome once again to Introduction to Programming. Today, we're going to tackle a problem solving by looking at a little example of a real world problem I've had and how I've solved it in Python. And hopefully, that'll give you some idea of the kinds of techniques you can use when you're really poking at a programming problem. So, let's give that a go. Let's start with a little warm up exercise. I want to talk a little bit about median finding. Median is a statistic on sequences of numbers. If you have a sequence of numbers, the median is the middle element. Uh, if you put them all in order, sort them into order, and look at the middle. Why is that an interesting statistic? Well, because the mean is a little confusing. If you ask what the mean salary is in the United States, the average salary, it's quite high, but it's quite high because of billionaires and that sort of thing. Uh, if you ask what the median salary is, it's a much lower number because all those few billionaires don't count uh, extraordinarily much in the grand computation. So if we have an odd numbered sequence, it's clear that there is a middle element. If you look at a sequence with the sequence 1, 12, 17, then it's pretty clear that the middle element 12 is 12 in that sorted sequence. But of course, if I have a sequence like 1, 12, 17, 22 that's not uh, odd in length, then there is no middle element. And there's various things people do in this case. Sometimes they return the last element from the lower half. Sometimes they return the average of the two middle elements, which is a little weird because now the median's a number that's not even in the list. What we're going to actually say is that odd length sequences don't have a median element. Sorry, that's not a thing. So we'll return the median element if there is one, and we'll return none otherwise. So how do we write a function like that? What's our thought process? Well, we're going to define a function. We're going to call it median, and it's going to take a sequence as an argument. And we know we're going to have to think about the length. And if the length is even, and this is a test, this mod 2, this percent 2 is read mod 2. It says the remainder after division by 2. So if nseq was 6, then the remainder after division by 2 would be 0 because it divides evenly by 2. 7, on the other hand, doesn't divide evenly by 2, and so the remainder is 1. Well, if the remainder is 0, it's even. If the remainder is 1, it's odd. So this is a very fancy test for whether the length of our sequence is even or odd. And if it's even, we just want to return none. So that's one of the tricks in this kind of problem solving, is to get the sort of special cases out of the way right away. So we are like, well, there's sort of a weird special case, which is even numbers. Fine. Let's check for that case right now. And then I said that it's the middle of the sorted sequence, so we will apply the function sorted, which given our sequence of elements, reorders it. And that we'll call that reordering. Notice that this doesn't change this argument. Remember, the variable sequence, this parameter sequence, is pointing at a list, refers to a list. We can mutate that list, and if we change that list around any, the caller will see it. That isn't probably what we want in this case. So one of the nice things about the sorted function is it makes a copy of the list and sorts that. And so now we've got a new list to work with and this one hasn't been messed with. So now we just want to find the middle element. Well, what's the middle element? Well, we said the thing's odd. And so if we add 1 to it, so for example, for 7, we'd go to 8 because it was odd. For 5, we'd go to 7. Or 6, So we're going to make this be an even number by adding 1. And then we're going to divide by 2, rounding down. So, so effectively it rounds the original answer up. This slash slash is Python's integer division operator. It divides by 2, throwing away any fraction. And so does this work? For a 3-element list, n equal be 3. 3 plus 1 is 4. Divided by 2 is 2. No, I'm off by 1 here. Interesting. Interesting. So I've got a bug. That's interesting and worth thinking about. So what I want, right, is if I have a 3-element list, the elements go 0, 1, 2, and I want this to return 1. And so if I take 3 minus 1 is 2 divided by 2 is 1, I get the right answer. What about if I have 5-element list? Then I want element 0, 1, 2, 3, 4, right? And so I take 5 minus 1 is 4 divided by 2 is 2. So that was a bug. That was absolutely a bug. And in fact, at that point, I don't actually have to subtract the 1 because this is already rounding the right way. There again, it divides and throws away the fractional part. So if I get 3, then 3 divided by 2 is 1.5. So we say 1. If I divide 5 by 2, I get 2.5. I throw away the 0.5 and get 2. So this is actually good enough. And now, having sorted all that out, and notice that, I'm sort of thinking through it as I go through the problem, right? I'm not just blindly following steps. I'm thinking, is this step right? Should I check my work? And I'm working through it mentally with examples, right? Because I really want examples in my head about what's going on. And now, having found which index is the middle element, then we return our sorted sequence, return that middle element, and off we go. So if the sequence is length 1, 1 divided by 2 is 0.5. We throw away the fractional part and we get just 0. And so it'll return the 0th element. It all looks good. And so that's sort of this process, right? Now I have a nice median function. I understand its behavior and all the test cases and stuff. So that's a good warm-up exercise. Let's talk about this in more detail as we work through a fancier exercise. The other day I needed to add up a column of numbers. This is a little bit of a fudge. I've had a program lying around for years that adds up a column of numbers. I mean, for decades, really. But it's been written in what's called Bourne shell script with sed and awk. And so it's pretty ugly to read and test and maintain. I decided that for reasons that I'll talk about maybe in some future video that I wanted to rewrite it in Python. So I need to add up a column of numbers. I wanted to do it in Python. And so I want to work through how we might do that, how I might have gone through that process. And problem solving always starts with, well, what have we got right now and what do we want to have when we're done solving the problem, right? What do we have? Well, I have text. I have a file with numbers, 1 per line, and I'm happy to present those on the standard input. We've talked previously about standard input. And so I want to put onto the standard input a bunch of text lines, each one with a number on it. And what I want to get on the output is, on standard output, is the sum of the numbers. So it's a pretty simple specification. Read the column of lines, spit out the sum. There are some details that are going to matter. We'll think about those as we go along. So what do we need to get what we want? Well, we're probably going to need to import standard in because that's probably the easiest way to read lines from the input. We're going to need a loop of some kind that reads lines from the input. We need to keep track of our sum. So we're going to do what's called a running sum. I'm going to think about this as, sort of the adding machine that we've built before. Each time I read a number from a line from standard input, I convert it into a number. I add that number into a running sum. And then at the end, I print the sum. So this is practically pseudocode already. We practically, sort of already see what lines of code we're going to write. So now we turn this into sort of real pseudocode. We have that for loop from the files lecture that'll read one line at a time from a file. We start a sum at 0. Each time we have a line, we read a line, we strip it off white space from the beginning and end because there might be garbage white space that'll confuse the number conversion. We convert it to a number and we add it to our running sum. And at the end, we have to print the sum. So there's that. So we have a pretty good idea of what we want this program to look like already, and we haven't written any code yet, which is great. So we need, here's more detailed pseudocode. We need a statement to import standard in, a statement to make a sum variable and start it at 0. We need a for loop that loops over the lines of standard in, a statement to strip white space off the beginning end of each line, a statement to convert the line to a number, a statement to add the number to the sum, and a print statement. So it looks like we got about 7 lines of so-called pseudocode. This isn't Python, but it tells us what Python we might write. So here's, more like pseudocode. This is sort of our things, written in English. So notice this isn't Python. I can't feed it to the Python interpreter. It will just refuse. It'll say syntax error all over the place because we didn't use the right syntax. But this is our idea. Set the sum to 0. For every line of standard in, strip that line to get the white space off the ends, convert the line to a number, add the number to the sum, and then at the end, when we're done reading lines from standard in and standard in's done, then we print the number. Okay, now we understand what we want to do. We have a plan, and this starts to look a lot like Python code. Let's see what happens when we really do it. Let's actually write the code in question. Let's just pop open our editor, and I'm going to actually paste the pseudocode copy and paste it into my editor. And we're going to just make it be comments in a Python program. And we will go back and remove all those comments as we write the lines of code that they represent. And now we've got ourselves some lovely Python comment pseudocode here. That's fantastic. Let's start with the obvious thing. Some numbers 1 per line from standard in Bart Massey 2021. So now we got our things set up. Let's just look at this and put these lines in set sum to 0. What does that mean? Well, we're keeping a running sum. We probably want to keep it in a variable. The value probably wants to be a number. We have our first interesting question, right? Which is integer or floating point for our numbers. For now, I'm going to assume integers. We'll leave the floating point question for another day. Let's assume floating point. It's more general, but that means that we're going to get some funny dot zeros if we're not careful on the output. So right now, sum is 0 for every line of standard in. Oh, that means we need to have imported standard in, which we forgot to do. From sys import standard in. Now I've got a lovely standard in that I can play with. And for every line of standard in, strip. So we're going to strip off the white space from around the line. Whoops, I don't have my comment in the right place. I wonder if I can just drag these. I cannot. That's a break point. Okay. And then I'm going to convert that line to a number, and Oops. Num, I didn't mean to undo that comment, but we were about to do it anyway. Equals float num text. We add the number to our sum. So here we say sum equals sum plus num. Maybe num's a terrible. I can live with it. And then when we're done, and so I'm going to start getting rid of these comments because they aren't helping me anymore. I've discharged, as we say, their thing. And then at the end, it says print n. What the heck's n? I don't know what n is. What do we want to print when we get here? Oh, right. We want to print the sum that we had. All right. So now we got ourselves a little program that supposedly reads a line at a time from standard input, converts that line into a floating point number, and then adds it to our running sum. Let's see what it does when we run it. Let's run it. And it's asking us for numbers. How about 3 plus 2 plus 1? And then we have to figure out how to tell it that we're done inputting numbers. That's an interesting question. I'm going to guess this. Yes. There's a thing called Control D, which lets you print things. Well, but no, it crashed. It crashed. It didn't finish correctly. So let's try it again. Or at least try to figure out where its output went. That's interesting. Let's stop it. And let's run it under the debugger and see what happens. That's probably the easiest way. So step over the import, step over this. In fact, let's put a breakpoint right here. You can click over here and get a breakpoint going, and we'll continue to the breakpoint. And now we should be here. Oh. No. Huh. All right, so Moo isn't so great for running programs that process standard input. We're just going to do the obvious thing here. We're going to hit save on this one more time, close Moo, and start working with this on the command line where we can actually work with it. So we'll go over to our examples code directory. And make sure our program's what we think it is. There we go. Now let's try it. 3, 2, 1. I hit Control D, which is Unix's way at least, and Mac OS's way of telling it that we've got to the end of input. And it says, oh, 6.0. Okay, so the 0.0 there is annoying, but it does mean that because we're processing floating point, 3.5 plus 2.5 will be 6.0, which is great. Maybe we have a lot of numbers of some kind. Well, first of all, what happens if we feed it no numbers? It says 0, which is reasonable. 0 is by convention the sum you get when you don't have any numbers. I can live with that. Let's try it with a big thing. Fact. Let's try it with a big random thing. So let's make a new program. Let's say 10,000, the range 0, 1 onto standard out. Or that's implied. So let's actually look at it and try it out. Uh, so there's a function called random in the random package. See what this does when we run it. Hey, look at that, a whole bunch of random numbers. So we'll put those in a file. And now let's see what happens when we sum those. We should get a thing right around 5,000. If we don't, then something's weird, because on average these numbers will all be 0.5 and there's 10,000 of them, so they'll average out to about 5,000. Hey, 5010. That's pretty darn close. And if we sum it again, we get the same answer, which is good news. It's deterministic. So it looks pretty good. Looks like we got a sum program. This is the kind of thing that computer scientists, system administrators, programmers do every day. We have a little problem. We need to solve it. We grab a convenient tool. In this case, Python was that convenient tool, and we go ahead and solve the problem. It's just the way we work. You know, we ran a test. We added some numbers by hand and saw that it got the right answer there. We ran this other test, which, doesn't give a perfect answer. We don't know what the real answer is, quote unquote, for our file of 10,000 numbers, but the fact that it's about right makes us pretty happy. Another way to do it would be to use some numbers that we do know are right. Trying to think if there's a fast way to generate a whole bunch of numbers and add them up, but it doesn't matter. It's fine. What about non-number lines? What happens if we feed it a line that isn't a number? We haven't tried that yet. That's a thing that'll happen in the real world once in a while. Yabba dabba do. Can't spell yabba dabba do, but there we are. Oh no, could not convert string to float, so it just crashes. Is that okay? Probably, right? There are things we can do about that we haven't talked about, but it's not the end of the world either. It certainly tells me that I need to go back and look at my lines of text, which is fine. Um, and yeah, we saw that it prints 0 with an empty file. So there we are. Now, you might have thought that I'd need a list for this, that I'd need to store all the numbers in memory. We don't need it, right? The running sum is enough to keep track of what we need to keep track of. We're only interested in this thing, so we don't overcomplicate things. It's really super easy to make things more complicated than you need to. Another real problem with having a list is that it might be too big to, list might be too big for memory. So I could easily have a terabyte of numbers on my disk. I don't have a terabyte of RAM, and so Python might literally run out of memory if I made my input file too big. This program reads a line at a time, so it actually will process my terabyte eventually and sum up all the numbers just perfectly happily. So let's talk about some of the things. Trying things out is great. When you're in doubt about something, go to the Python REPL and type at it. I do that all the time to see what's going on. Stepping in the debugger is great. Prototyping is great. Breaking things into small pieces. I usually try to get one function per piece. And so for these little functions I've built, that's great. For a bigger program, I'm probably going to break it into small functions. This stuff's the essence of problem solving. You need to practice it. You need to find problems that are interesting and poke at them by writing programs, one function at a time. breaking things down, writing pseudocode, trying things out in Python, asking questions, stepping in the debugger, doing all the things you need to do to get comfortable with this sort of art form of writing Python code. It's a lot of work. It's hard. It's challenging. It can be so rewarding when you get it done, when you start to make progress. Thanks much for listening. Always great to talk to you. I look forward to doing it again soon. Please stay safe and well out there in these difficult times. Take care.